Okay, we're starting circles finally. We've been on a lot of pointy shape. We've been on triangles for a while. We have polygons there, quadrilaterals. Now we're on circles. So this is obvious, but we know what a circle is. It's a collection of points that are the same distance from a single point. So instead of going, this is a circle, that's the actual definition. There's a center point, and then we can actually write that down next. There's a center point, and all of the points in this circle are the same distance from that point. So that's actually the actual definition of a circle, a bunch of points such that they are all the same distance from its center. Now we actually name circles by their centers. So if we see this little dot in the center here, we would call this circle, I have it there, A, because the center is A. So that's how we know we're talking about that circle. The center of that circle is named A. Now you hopefully know this, but a circle has, since it's a full rotation, if I did a full turn, if I spun back around and came back around to the front, I turned 360 degrees. So a circle opens all the way around, that's 360 degrees. Now we got a lot of vocab we're gonna write here. Most of these first two lessons in particular are a lot of vocab. So we wanna stay organized, copy stuff exactly down, so we have it all nice and neat. So a radius. A radius is a segment connecting the center to any point in the circle. Again, hopefully you know most of this stuff. You've definitely seen it in elementary school and middle school. But a radius connects the center to any point. So here's the center. We'd call that a radius. Going from the center down to any point on the circle, this is also a radius. We could draw a lot of different radii, is plural for radius. Now we also have a diameter, which is a segment that passes through the center, and ends on the circle. So you should put an and there. A segment that passes through the center and ends on the circle. So a diameter passes through the center, but then also starts and ends on the circle. So diameter basically cuts the circle in half. Again, that's a diameter, but I could also draw another diameter. I could draw an infinite amount of diameters. As long as they pass through the center of the circle and end on the circle, then that's the diameter. Now a chord, we may forget what a chord looks like. A chord is a segment that connects any 2 points on a circle. So the difference between a diameter and a chord is the chord does not have to pass through the center. So this is a chord. If here's 2 points on the circle, a chord is a straight line segment that connects them. So it can pass through the center, but then we'd call it a diameter. So a chord just has 2 endpoints on the circle. There's another chord. There's another chord. Yeah, it just needs to have 2 endpoints on the circle. Next word we're almost through, is secant, is how you pronounce this. This is the line that cuts through the circle. So the way you want to remember this is a secant cuts, right? Sec, cuts through the circle. So a secant is a line also. So this is an important distinction. Notice I had them in bold. A line has arrows on the end, right? So a line goes through the circle versus these are all segments that start and end on the circle. They don't have arrows. So a secant cuts through and has arrows on the end. It's a line. Last one we have here, for the lines at least, is a tangent line. This is a line that touches the circle at one point. So I can move this to the outside. That's a tangent line because it touches. So once again, secant cuts, tangent touches. Think of the T's there to help you remember that. So this is a tangent line, and right where it touches, this point right here, right where it touches the circle, we call that the point of tangency, the point where the tangent line touches the circle. So I know this is a lot of vocab, guys. Obviously, you're going to have this all in your quiz, super easy points. But we need to have this so we can start talking about circles and referencing things in there, and you know what's being talked about. So with this example here, we are going to identify all of these things, at least one. There could be multiple in the picture. We're going to identify at least one. So to start with, What is the center of this circle? This one should be easy. What point is the center of the circle? A. A is the center of that circle. Now let's find a radius. I will tell you there are 3 in this picture that you can pick. I'm going to give you one, and then you need to give me another. So one possible radius, because a radius goes from the center to the outside, AE is a possible radius. Give me another one. There's 2 to choose from. So you could have chosen AC or AB. Those are all radii because they start at the center and end on the circle. That's a radius. Now we're looking at a diameter. There is only one diameter in this picture, so I want you to look back to your notes and tell me what the diameter is in this picture. Cuts through the center and ends on the circle. That should be EC. I'm not going EAC, I'm just saying the endpoints, right? EC is the only diameter drawn. I could draw a lot more though. It's the only diameter drawn. Okay, now a chord. There are several chords here. Actually, there's 2, technically 3. So I'll give you one chord and you can give me the other. So even though EB is a line, if I call it, if I want to talk about just this little piece here, I could say line segment, which is just like this. EB is a chord, and then I'm only talking about the line segment. What's the other chord in the picture? DC is the other chord in the picture. Technically, you could also say the diameter is a chord. It's just a special type of chord, but these are 2 as well. Okay, so secant, remember that secant cuts. So there is only one line that cuts through this circle. What is it? Line EB. So since I'm calling EB a line now, if you remember way back to our very, very first unit, I need to show that with the little arrows on top. So that's the difference between line EB and segment EB. Line EB is the secant that cuts through the circle. The segment EB is the chord that's made up right there. And tangent, there is only one tangent in this circle picture. It touches, tangent touches. What is it? DF, line DF, once again, when I'm gonna put DF here, I'm gonna put a little mini line on top. Touches at what point? What's the point of tangency? That this line touches the circle. D, right there. We'd call that the point of tangency. That's where the tangent touches the circle. Okay, so we're going to do one more thing here. That's not so much vocab. We're going to be talking about the relationship between diameters and radii. Again, that's the plural of radius. So if the radius goes from the center to the outside, and the diameter has to go through the center, the radius is actually half the length of the diameter. So if we are given the diameter, we just take half of it, and that's the radius. So for A, the way this is labeled here is telling me this whole thing measures 12 centimeters. This is the diameter. Again, the diameter is 12. Therefore, the radius has to be half of 12, which is 6. So that would be from here to here is going to measure 6. The whole thing measures 12. So trying this one, if the whole thing is 25, that's the diameter, what is the radius then? What's half of 25? Well, it's not going to come out evenly, but we can still say what it is. Half of 25 is 12.5. And hey, there's your answer. Now we're going to be doing a lot of word problems at the end of this unit, so we want to get used to them. But it says Mary has a round flower pot. So hey, there's her flower pot. The distance from one edge to the other going through the center is 14 inches. Going through the center is 14 inches. What is the radius? So we know what to do. Go ahead and try it. Find the radius. If the distance here is 14, what's the radius? 7, right? The radius is going to be 14. Oops, that's 17. 14 divided by 2. which is 7 inches. I should put the units on there. But again, we just had to be able to visualize the picture. We have a round flower pot, distance from one edge to the other, going to the center. Get used to visualizing these. So obviously, going in reverse, the diameter to the radius is the opposite, right? If the radius is half the diameter, then the diameter is double what the radius is. So I'm given a radius here because I'm going from the center to the edge of the circle. So we need to double that, and that gets us to be our diameter. So what is going to be the length of the diameter in this circle? Well, our radius is 9 times 2 to get the diameter, it's 18. Oops, change colors there. And that's it. If I'm given the radius, I'm going to double it to get the diameter. If I'm given the diameter, I'm going to halve it. So reading this one again, we want to make sure we can envision it. John has a round swimming pool. So here's his round swimming pool. The distance from the center of the pool to the edge is 3 meters. So hopefully we can envision that. Center to the edge is 3 meters. That's the radius, center to the edge. What is the diameter of John's pool? Go ahead and find it. What is the diameter of John's pool? Well, double it. It's 6. Hopefully this is super easy. These are going to be super easy questions. 3 times 2, 6 meters. On your test, you're going to have a few just like that. So super easy. Just don't accidentally halve when you should double or vice versa.